Hello and welcome to another episode of Peep and EIP and EIP Focus series. I'm your host Pooja Ranjan, and today we are going to talk about the EIP-778 Ethereum Node Records, ENR. EIP-778 is a standard track networking EIP. According to the abstract provided in the proposal, this defines Ethereum node records, an open format for P2P connectivity information. This proposal is currently in the last call status and has already been implemented in some of the clients. Along with the author today, we are joined by David from the Besu team, Brent and William from the Ethereum cat herders. So without further ado, let's welcome author of the proposal, Felix Lange. Thanks for joining us, Felix. Please share a little bit about yourself before we dive into the proposal.
Yeah, right. Hey, yeah, so I've been working on Ethereum since the beginning, I guess. About the P2P networking and stuff, but we kind of stopped doing those, I don't know, mostly because I feel like people were not so, weren't always so interested, and I'm not the best presenter. So yeah, I'm not a very, I don't know, like public person, I guess. But yeah, I don't know. But I mean, I'm really happy to be on this thing here and, you know, just talk about my stuff. So yeah. Yeah, that's really about it. I work on Go Ethereum most of the time. So this is like, you know, if you've ever interacted with me online, it's probably been through the Go Ethereum repository, because yeah, I'm very active there. Yeah, so maybe a little bit, I don't know if my slides are already like visible to everyone. I don't know, can you confirm? I did share my screen, so I guess
yeah, we can see them.
Cool. So yeah, I made some slides. Basically, so about the 778, it's kind of interesting because yeah, I should have started with this slide first, so I'm just going to go to the second slide straight away. It's the basically, one thing to know about EIP-778 is that it's really old. So I submitted it in November 2017, which is like 3 years ago, and we submitted it because when we were working on the early version of the Discovery version 5 for the Light Client project, which is still ongoing, as is the Discovery version 5 project. So both of these projects are still ongoing. But when we were working on that in like early 2017, we kind of noticed that there's this problem, which is that in the Discovery version 4, it's the protocol that all of the nodes use to find each other on the internet. The problem with this protocol is that it doesn't really contain a lot of information about the nodes. So it's kind of weird, because it's supposed to be this protocol where they can all find each other, and they can, but the only thing they can talk about is, you know, like what's my IP and stuff. And you can see that here. So basically all of the information that can be relayed is this information. And that was just a little bit like, it wasn't really enough, because like, especially for the Light Client, we just need like a lot more metadata to really assess if this particular node is like a good candidate. And it's always been an issue, especially with the Light Client, that most nodes are not Light Client server capable. So it means that if you find a node in the Discovery, it like the chances that it actually has the LES server enabled are pretty small. So it would be super nice to just kind of know, you know, does this node have the LES server enabled or not? But there's no way to tell if that's the case using the protocol. And then we kind of started thinking like, you know, what would be a good way to do that? And we didn't just want to add like a single flag that says, is it LES server or not? And so this question kind of sort of became ENR, which is a general format for saying such things about nodes in the Discovery. And we actually, the ENR is actually deployed. So the fact that it's last call is kind of weird, because I feel like, you know, it's just, you know, it's in active use, and it's been in active use for quite a long time. So yeah, I don't know. With the networking EIPs, I think nobody really figured out yet how to assign the status properly, because they are not included in the hard fork or something. They just, you know, get shipped. And so basically, yeah, the ENR is live and we are using it. And the first real use was in the DNS Discovery, which is also live and in use, and that is the EIP-1459. But we're not talking about that one today, at least not so much. But that was basically the first time where we really started using the ENR in ETH1. And notably in the Discovery version 5, which is not used by ETH1 at this time, but it is used by ETH2. This one actually uses ENR as the native format, and so there ENR happens, like, basically it deals with ENRs like all the time, whereas in the ETH1 the ENR is more like this like side thing that some nodes can do, but it's not mandatory in ETH1. Anyway, so yeah, let's get back to like what's the idea behind the node records in the first place. So a good analogy for the node records is that it's like business cards for nodes, right? So it's like when you meet someone in real life and you're, you know, at a conference or something, probably they're going to give you a business card, and on this business card is going to say, hey, I don't know, Adam something, and here's my email address, and here's my phone number, and, you know, I'm a, I don't know, venture capitalist or whatever, you know, people put on their business cards. Maybe it has a logo on there, I don't know. And that's like kind of the analogy with ENRs. Is like this, it's a place where you can put information about the node, but also, and this is quite important, and I forgot to put it on the slide, it's size limited. So basically there isn't like an infinite amount of space. So if someone would give you a 2 meter by 2 meter business card, you wouldn't really be able to put it in your wallet or something. So business cards are usually pretty small, and it's the same with the ENR. They are very small, and actually they are 300 bytes in size, and they cannot be larger than 300 bytes. So this is guaranteed by the specification. And inside of the ENR, you will find network connectivity information. So for example, you have the IP and port and public key and stuff in there, which is very useful for that. But you also have protocol specific metadata. For example, you have some metadata which is related to the ETH protocol, and that says, you know, like which particular fork of the Ethereum blockchain you're on, which is very useful. So you can, if you find a node, you can immediately check if it's on the same Ethereum blockchain that you want to be on with your node. So that's like one of the things that it can do. And yeah, the purpose of these is not just like it's relaying these, but it's not limited to the DHT. So we use the DHT system for relaying nodes most of the time. But with ENR, since it's supposed to be kind of a standalone format, it can also transcend systems. So it's like you can use ENRs as like an interchange format if you have more than one discovery system, and we will actually see an example of that in, yeah, pretty much now. So, but let's just look at the ENRs first. So this is what an ENR actually looks like. This is the text format, and this is the one you're going to see most often. And the text format is really just, yeah, the string ENR and then some base64 encoded binary data. And the binary data is RLP. So you can see the equivalent RLP structure here. So this is what this looks like. And you can see that in here, there's a signature, which I've truncated because it's very long. Then you have the sequence number, which is also quite important. And then you have key value pairs, which are basically the key. And then there's the value, and then there's another key and another value, a key and a value, and so on. And it's maybe easier to look at it in the like decoded form. So this is something that you can print using some Go Ethereum command line tools. You can see that this node record, which I've shown here, it contains this information. So the information is, it has this Ethereum protocol metadata. It uses the identity scheme v4. It has this IP address, this public key, and these ports. And yeah, that's really about it. And maybe a bit about the signature and the sequence number. So in addition to the metadata, the node records are always self-signed. So basically, there's always a signature in the node record. It is mandatory, and it covers the complete content of the node record. And node records are always signed by the issuer, so they are signed by the node that they are describing. And this is very useful because the node record information, it cannot be changed by anyone who is relaying this node record. So if you give your node record to someone else, they cannot change the information that's contained in the node record because it's signed. But they also contain the sequence number, and the sequence number is mostly important because they solve the update problem in a system where these records are propagated. And I've made a little overview here that kind of shows that. So let's say we have a node record of the node A, and it has the sequence number 3, and it gives this node record to the node B here. And then there's an additional node record, which is the next version of the node record. So A updates its node record and updates it to the version 4, and it gives that version to the node C. And then somehow node D receives both copies of this node record. So it receives the one with the sequence number 3 and the one with the sequence number 4. And basically, the sequence number, it allows the node D to decide which record is newer. And in this case, it picks the one with the sequence number 4 because it's the higher number. So that's like the purpose of this, is that if the node record is relayed through multiple other relayers and it's also updated, then it's possible to decide which version of the node record is the newest one. So that's what the purpose of this is. And this is even more important in a situation like this, where you have, let's say, you have left side here, and you have something like the DNS Discovery on the right side. So these are two different systems containing Ethereum node records. And the node D here is basically pulling information from both of these systems. And if it discovers the node A in one system, but also discovers it in the other system, it can still decide which one is the better one. So in this case, the version from the DHT is the better one, but it, might as well just be the other way around, that basically maybe the DHT doesn't really have the newest version or something of that particular record. And then in that case, it could pick the other one. But yeah, this is like the purpose of the sequence number, and I hope it's clear now. And one final thing before we're basically done. So there is this other thing in here, which is the identity scheme. And this is another very interesting property of the node records. So basically in the node records, it's possible to say inside of the record which identity scheme is used. And the identity scheme, it determines how the signature is made. And the signature, you can see it here, is in most cases right now, because there's only one identity scheme which is defined, and it's the V4 scheme. It's a signature created by the SegP 256K1 key. And the current identity scheme is named V4 because it is backwards compatible with the Discovery version 4 identities. And but other identity schemes may be defined in the future. So it's an open area of research to figure out, like what other identity schemes make sense. And most importantly, the identity scheme is also the one that is in charge of saying what is the node ID. So you can see it displayed here. So the node ID in this case is derived as the hash of the public key, but it can be different with another identity scheme. And this is just something more to figure out. Yeah, and it's one of the important things about these identity schemes is that they are like a very sort of long-term thing. So we mostly have them as a protection against things like hash functions getting broken and things like that. So I think that identity, if there is another identity scheme, or if there's ever a new identity scheme, we will still be supporting the current v4 identity scheme for a long time, and we will also not usually define new identity schemes, but it's more like if there is an urgent cryptographic emergency that requires defining a new identity scheme, it's possible, but it's definitely not something we're going to do all the time. Cool. So that was it with the presentation. I hope it answered some questions. I don't know, but I guess there's actually going to be some questions, I hope.
Yeah, sure. Actually, that was a really good presentation. I think it really did set the stage very well. I just want to give David the chance to, if there's anything that you want to open up the Q&A with.
The only thing, can you go back to your slides for 1 second? I just wanted to see, I missed where this, give me 1 second here. I missed where the sequence number was. Is that just encoded right into the node ID? Okay. Okay, thanks. Yeah, that was the only question I really had.
All right. So then maybe I'll start off with, so what exactly is included in the EIP? It sounds like the discovery protocol is already there. It sounds also like this is something a bit more protocol related than saying that it's actually the discovery v5. So is it the data format that you want to be using? And what exactly is a part of the EIP and what isn't a part of the EIP?
Oh, also, I just noticed I was muted, so I was talking to myself earlier. So I have the EIP up on the screen right now, which might be very helpful for this discussion, right? So this EIP is very old, and it only defines this format. And there is nothing about the protocol or anything like that in this EIP. It is really only about this format.
Does that change with Discovery v5?
So in the Discovery v5, which is not in an EIP, we are using this format. So the Discovery version 5 uses this format in the protocol specification. I can actually show you that. So if you go to the Discovery version 5 specification, which is here, and you can see it, and you can search for ENR. I guess it's, yeah, at some point it's gonna be in there. Where is it? Well, yeah, I mean, it's here. So like basically we are inside of the Discovery version 5 protocol, we are using these ENR objects. And then the idea is that like these objects are encoded as specified in here. So that's like the thing, yeah. I hope it, does it clear up your question or?
Yes, that does absolutely answer the question. As in the data format that's used in v5 is what is the EIP here. It's saying that
yeah, but it's not just in v5, and this is quite important. So the thing is that if you check, for example, we are also using the same format in this EIP. So it requires the 778 because it is the same format. This one was created in 2018 and we are currently using it. It's still in draft for some reason, but in practice, this is deployed and used. And it's the same for the EIP-868, which is an extension to the Discovery version 4 to allow relaying of Ethereum node records. And this EIP is also implemented by most clients at this time. And it is another way of using the ENRs, but it has nothing to do with the Discovery version 5 because this is an extension for the Discovery version 4. And we are also using the ENR in here and the sequence number in here. So, yeah.
So 868 is basically an EIP to say this is a way to find and use the new ENR format nodes, right?
Yeah. So we added the 868 because we wanted to have a way to actually find all of the ENRs. So it's kind of yeah. Most of this came about because of the DNS. So the DNS discovery, which again we are using already, is like the system where basically the way we are generating this is that there's a DNS name, and behind this DNS name in text records are contained ENRs. And we didn't just want to put like a static list. So the way we are generating this list, which gets put into this DNS name, is by crawling the discovery version for DHT and then checking like if the node actually like has an ENR using the EIP-868 ENR request.
Okay.
So basically we are crawling the DHT and then we're sending the ENR request to all of the nodes. And if they come back with an ENR response, then we include the ENR in the DNS discovery tree. So
Okay.
that's kind of how this works.
Okay.
But this is kind of, they are not really used for anything else though. Like the ENR request is not really used. I mean, you can use it on the command line if you really want to. There's a command in the Go Ethereum P2P toolkit for checking like if the node support, you can ask for the ENR, but it's not really gonna give you like anything useful,
Okay.
Do you foresee the need to extend the ENR format coming up, like, anywhere on the horizon, or do you think that this is it for, in terms of the, like, what an ENR object is going to look like?
Well, so the ENR object itself, I mean, it's like, I should have noted that probably. So in the ENR specification, it has these key value pairs, right? And these are sort of like the built-in key value pairs. So these are the ones that you can put, and they're defined as part of the main ENR format specification. So it says, like how to encode an IP address and how to encode an IPv6 address and things like that. But actually, it's not like the only key value pairs you can put. And you can see that in the dev P2P repo, we actually have a directory for ENR entries. And for example, here is the specification of the ETH ENR entry. And it kind of says, like what's contained in the entry. So, and there is nothing really, it was also proposed in an EIP, by the way, which is EIP-2124, which is also in last call right now. And this one actually does, so basically this entry is specific to the Ethereum 1 blockchain. And in ETH2, they are also using ENR entries, but for some reason, I didn't really put them into this directory yet. I should probably do that, but basically they have them in the main ETH2 specification. Somewhere there's a section that says these are the ENR entries, and they have them.
Interesting. So you're saying even if there are new fields that need to be introduced, the ENR format is extensible, so those could be added in. This is sort of like a lowest common denominator. An ENR object must have these key values, but other key values could be added.
Yeah, actually, there are no mandatory key values except for ID.
Oh, I'm looking at that right now. Now I see that. Yeah.
And so, and then, but the thing about that, yeah, they are all optional except for ID. Which is weird. I do have some regrets regarding this format. I can say after, after 3 years of looking at it.
It's interesting.
Well,
I mean, doing it over again. What would you do?
Well, I'd probably like make the ID not a key value pair because it's mandatory, and it's like, it's a bit useless to put it in the body of the, like, I mean, if you think about it, like the structure of the node record is basically you have the signature, sequence, and key value pairs. And you can see the same here. It's like the content of the record is like sequence, number, key value pairs, and then there's the signature in front. So this is the full structure. But when you actually have to validate the record, what you have to do is you have to basically extract this part here, like the content part, and then verify the signature over it. But in order to verify the signature, you also have to know what you're supposed to be verifying it against. So you need to actually check the key value pairs. So the way it works in the implementations is that they do one pass over these keys and values, and then they have to find the ID key, and then basically once they found the ID key, they can kind of check like what type of signature is it supposed to be. And if it's supposed to be the V4 one, then they also have to go to this entry, which then has to exist because it's a V4 record. So it needs to have a public key, and then they can verify the signature against this public key. And it kind of feels like, because you always have to do this lookup for the ID key first, it feels like it should just be, you know, like it shouldn't be a key value pair. And then the other big regret I have is obviously maybe not using SSC. And this actually came up multiple times in the ETH2 discussions, like why it's using RLP. And it's mostly because this format is so old. I mean, SSC didn't exist when we made ENR. But yeah, nowadays I feel like, you know, it's kind of, yeah, well, you need an RLP decoder to look at the record. And I don't know if that's like, I don't know. I mean, it doesn't bother me personally, but I know that it's like, some people thought it's a bit of a bummer that you actually have to use RLP to decode this, but like, yeah, I don't know. Can't have everything.
And they weren't able to do something like put SSC in for ETH2 because of compatibility.
No, they actually the ETH2 ENR entry is encoded using SSC.
Oh well, there you go.
So
having it in ETH1 as well or not?
What do you mean?
We will be having this discussion soon in ETH1 as well for having our.
Yeah. There will be some SSC stuff coming up. Yeah, that's true.
Mm-hmm.
But what I mostly regret is just making the format like I should have, like independent of the encoding, because now I had to justify the RLP decision many times in the past, and it feels super weird because at the time when we made this specification, there was basically, it was like the canonical format for everything in Ethereum, and I didn't really think about it too hard. I just kind of thought, you know, let's use RLP because we use it everywhere for everything. Sounds like, you know, perfect choice. And it kind of turned out that, like, you know, people later were like, you know, didn't like it or something, or I don't know. But in practice, you know, it's totally possible to mix these things. Actually, now that I'm very curious, and we should probably just kind of check if, no, wait, what's it? It's these 2.0 specs, I guess. Yeah. Yeah, there we go. So here you have it. It's the, you have the ENRs, and in the ETH2, they have the AdNets key, which contains an SSE bit vector, and they also have the ETH2 key, which contains the fork ID. And the fork ID is like this SSE structure. I don't know. It's pretty much like the ETH key, just SSE instead of RLP.
Interesting. On a more general note, how much do these ENR records in general add to latency in terms of ethers? I don't know how relevant they would be. I guess they would be relevant to syncing, but also in terms of transaction propagation. Like, is there a concern that if there becomes too many fields, that it's going to increase client latency to a significant degree?
Well, I mean, so one important thing about them is that they are size limited, which I kind of mentioned in the beginning. And it's also, I hope it's mentioned a lot in the Peep. Like, it really has the 300 bytes limit. And it's not directly related to the latency because these are used during the discovery, right? So when the peers are discovered, which is like a concurrent sort of process, like basically discovering the peers is not like directly related to what happens when the peers are actually being used. And
already found it being queried, yeah.
Yeah. But that said, so yeah, I mean,
So then why
yeah,
is
it's
the
not really
300
like
Go ahead. Sorry, I didn't mean to cut you off.
no, it's no problem. So the 300 bytes limit, it exists because there has to be a limit. It's just a fact. But also, if you check, for example, if we check the, it's most important. For example, if you check the Discovery version 4 specification, right? So in there, it's like I guess they have it. Wait, where is it? Oh yeah, it's here. So so in the Discovery version 4 via protocol, the maximum size of any packet is 1280 bytes. And this is because of networking reasons. I don't really want to go into it too much, but basically it's very good that it has this limit, right? And in the Discovery version 5, it's the same. So the maximum packet size is 1280 bytes. Right. So since that's the case, it's like, you know, and we don't really want to go ahead and relay these things across multiple packets or something. So basically, it's like it kind of makes sense to be limited in some way, simply because in the Discovery protocol, the message size is limited to the 1280 bytes. And then in the Discovery version 4, in the ENR response, you can have a single ENR. So this is going to be up to 300 bytes. So it doesn't really touch this limit too much. But then when you go to the Discovery version 5, again, you can see that there is the nodes response. And then the nodes response actually have multiple ENRs. And here it's like the size limit on ENRs is directly determines how many nodes you can transfer in a single packet at one time, right? Because the limit for the packet is 1280 bytes, so you can put at most, four ENRs. Yeah, but there's also some protocol metadata around it, so maybe safer to just put 3, right? And obviously, if the ENRs are smaller, you can pack more, but you know, like there is like some like sanity limit, which is that, you know, probably you're going to be able to put like 3 or 4 in the packet. And if we would allow like arbitrary size ENRs, then this wouldn't be possible. Like you'd basically have like 1 per packet or something, and then that would really hurt the latency, because you would have to actually, like, I don't know. And then also in the DNS, it's different again, because in DNS, the message size limit, at least for UDP DNS, is actually 512 bytes. So there, it totally makes sense that the ENRs are limited to 300 bytes, because the 300 bytes limit applies on the binary encoding, and then it will inflate a little bit when they are encoded as the base 64. So that will make them a bit larger. And in the DNS discovery, they are input in the text record in the base 64 format. So we are basically very close to the DNS message size limit already with this.
Mm-hmm. Very interesting.
Yeah. It's kind of a trade.
Please go ahead. I didn't mean to go.
No. I nothing.
So, I mean, I was just curious about this ET2 thing. Like, I had a question in my mind out of curiosity. This proposal, is it helpful in identifying the, details of a node operator, even in the case of ET2, where Explorer can give back information to a node operator that your node is down or something?
Yeah, I mean, it could be used for that. It could totally be used for that. That's actually kind of an interesting thing. Yeah. So in general, it's up to anyone to put, you know, like to the node implementations. They can put whatever they want in there. It's mostly about like finding a standard. So that's like the thing. And then also we are always trying with the Ethereum P2P to make it not so identifiable, like the information. Early on, for example, we kind of try to avoid putting the like vanity information. In the general Ethereum P2P protocol, there is vanity information, and you can find it. For example, you can set your own node name, but also the node name is automatically generated to show, for example, if you go to the ETH stats, you can see them, right? I mean, these are these node names. They are in this column, in the node type column. So this information right here, this is the vanity information, and this is relayed in the peer-to-peer protocol. And in the ENR, we don't really want to put this information because, first of all, it's very large information, like it really eats into the 300 bytes. But also, yeah, it's kind of like, yeah, well, it might just get a little bit too easy to know, like, you know, what kind of node is it? Like, I mean, it's more like the idea with the ENR is more like for the kind of information that that is really relevant to, you know, the operation of the blockchain. Like what, like, for example, in the ETH1 ENR, we have the information about like the Genesis block and the forks that were applied in this implementation and things like that. And this is really the most important. And then like the vanity stuff is, it can be nice, but it's also kind of optional.
Yeah, great.
Yeah, go ahead. So maybe just a last couple of questions from me that I think are related to this. So it could be that I'm just off on a limb here, but I've been in some conversations about ETH1 node incentivization, as in on the ETH1 proof of work chain, incentivizing people who are running full nodes, even though they aren't mining. And I know one of the concerns that I've heard come up is that someone could just run one node and then just sort of relay it through a number of different IP addresses. You mentioned that in ENR, once it's created by the client, it can't be changed once it gets moved, once it gets propagated into the network. Does that mean that ENR might be a vector to see, like, you know, unique nodes on the network? Would it be able to prevent an IP spoof like that?
I don't think so, because it doesn't, like, it does not solve the Sybil problem in the very general case. So this is something that is, like, the Sybil problem is real problem in all peer-to-peer networks, and it's not something that can be fixed so easily. It's, yeah, generally considered unfixable even. Yeah, no, the signature won't prevent this. Like, you can always create another record with another signature with a different IP, and it doesn't really help you with that. I think the ENRs can be quite important for the incentivization. So in the light client protocol, there is some facility for the incentivization, and they are developing it even more right now. And for this, it can, for example, be, I mentioned this a couple of years ago when I first talked about the ENR, that basically the discovery of nodes, it doesn't always have to be, you know, just about the IP. It's more also, like, if you have some facility for discovering the nodes and seeing more metadata, you can also be a bit more picky about which node you actually want to use. And for example, if the nodes were to use incentivization, and basically what this would mean is you would have to pay them to download some blockchain info, then they could, for example, announce their general pricing range or something in the ENR. And this would be very useful, because when you would discover the node, even without talking to it, you would already kind of know that, you know, this node is offering service at a very high price or a very low price. And this is something that could be used for incentivization related things.
Oh, very interesting.
Great. So going on a little more tangent on this, I'm curious to know your experience as an author for this proposal. As you mentioned in the beginning, that it took a while to move from the one status to another. Is it, I mean, like, how would you describe that?
You mean, oh, my EIP experience? Yeah, I can say the EIP process is great, but for the EVM, I think it works pretty well, because it is very easy with the EVM to say exactly like, when is the change gonna activate. And once that's decided, then all of the implementations have to get it ready. And then there's hard fork and tests and so on. And then with the peer-to-peer networking, it's always kind of the problem that I think there are two problems. So one problem is it is not tied to the hard fork. So there is no need to, there's basically no need to define the hard fork. Sorry, I stopped the screen share. So the when the hard fork happens, it doesn't really influence, and most of the time we just ship the updates so that they would kind of be like available after the hard fork in the networking. But there's no requirement for that, and you cannot really do that. And then the other problem is that historically, like right now, we're in this unfortunate situation where Go Ethereum is very popular and everyone else is not so popular. And this is something that we in Go Ethereum, we really hope it will change, because it puts a lot of responsibility in our hands to get everything right. But also in Go Ethereum, we have been very, very, let's say we have cared about backwards compatibility a lot. And what this has resulted in is that other client implementations haven't really seen the need to implement these features in time. So basically, right now, we are still supporting, from the networking point of view, we can still talk with parity nodes from 2014 or something. No, that didn't exist back then. But, we can still talk with very, very old nodes, even now, even though they are totally incompatible regarding the EVM for these days. So it's like, if you would run the Go Ethereum version 0.9 point something, it would probably still connect somehow to some other node. And it's like, it's not the best way, because it means that, for example, in parity specifically, some of the EIPs are not implemented, the networking EIPs, and this is mostly because they didn't see the need until now to really implement them, and we never really turned off the support for the older version. And it means that like it was a very slow process, and we would really like to have more to be more strict about this and really define some deadlines where it's like you absolutely have to implement this feature by this time, maybe tie it to a hard fork after all. And in that case, I think the EIP experience would also get much better, because then it would be very clear to the editors that, okay, this is for this fork and this is for this fork, and this client has it, this client doesn't have it. It's something that right now, basically there isn't even like a list that says this client implements this networking EIP or something. It's more like, they just kind of like, I just occasionally run some tests on the implementations to see if they have certain features, and sometimes they do. And I mean, right now the BSO, for example, is very good. They have a lot of the stuff, and Open Ethereum, it doesn't have a lot of the features. So that's approximately what I can say. Nethermind also like halfway. I don't know, they have some but not others. And it's like, it would be nice in the future to have a more strict process for the networking changes. But then I'm also a bit fed up with this EIP proposal process, because it's very hard to get feedback, and I waited for feedback on my EIPs for a long time and nobody really said anything. So in the end, we just decided to ship anyway after waiting like a year or something for people to like, I mean, I don't have the screen share, but I could show you, like I made the, like here you can comment, and I put some like notices in the relevant chat channel and say, hey guys, here's the node records EIP, will you check it out? It's very useful. And people didn't really respond. And at some point we just decided, you know what, if nobody's going to respond, we're just going to go ahead. And this is not the best kind of situation, and I think I would appreciate it. I never really knew like where to put my proposals, and I think this is something maybe different now with the cat herders and the forums or whatever. Maybe there is a way, like magicians maybe there is actually a way to discuss these things now, which didn't exist before. I don't know. But for this EIP, it, like magicians, did not exist either, or maybe did, but I didn't know about it or whatever.
Thank you. Thank you so much for your feedback. I mean, like, one of the purposes of having these calls with authors and sharing about the processes is, you know, to making people aware of what changes are getting into the system. Like, there are certain changes that have been proposed and we are trying to implement it for the EIP standardization process, and we are trying to look into every proposals which are stuck for a while, maybe a year or two or more than that, in the draft status or the last call status, or have not reached to the final statuses. So we are trying to push them forward with the help of author itself to move along the process and get to the final status, as well as to let other people know that there is some standard available that you can start making use of. So for this particular proposal, I see that the last call period has already passed long ago. So we are proposing you to go ahead and create a pull request to change the status to final. And with the help of present EIP editors, we will try to move it forward along the process.
Yeah,
And,
well, that sounds great.
yeah, and not only for this this particular proposal, but for all the proposals which are there in the networking list, eips.ethereum.org, we are looking into one by one each of them, and then we'll try to get it through the right place. We are close to hitting the time. Does anyone has any final question, comment? Maybe David, if you have anything from Besu's side to share.
No, I think that covered everything I was looking to get out of this. I appreciate you guys taking the time.
Thank you for joining us today. So I hope that today's episode will help client implementers who haven't implemented it completely, and others who are trying to understand the proposal to, you know, and this proposal will soon move to the final status in the EIP standardization process. I believe the Ethereum improvement proposals are great work by contributors of Ethereum ecosystem, but maybe a little less visible. So with the help of this Peep and EIP series, we are trying to share more information to the community at large, sharing more and more questions, comments for the proposals that we can include in future episodes of Peep and EIP. Thanks, Felix, the Besu team, and our awesome cat herders for joining us today on the Peep and EIP talk. For people who are watching us on YouTube, you may find the GitHub handle of the today's guest and the rest of the participants in the description section below. If you have questions, comments, or concerns about this or any other proposal, or if you have any suggestion on which proposal to be included next in our show, please leave a comment, and you can always reach us on Twitter. If you like this EIP focus series, share it with other community members and let them know about Peep and EIP. Do hit like, share, and subscribe to the Ethereum Cat Herders channel. See you next week with Sam Wilson and Ansgar Dietrich to discuss EIP 2938 account abstraction part 2. Like on community demand, we are having a second part for this particular proposal. People had some questions that we could not answer in the first episode that we made for proposal 2938. So we are hoping to talk more on that proposal. Till then, keep sharing your love with us. This is your host, Pooja Ranjan, signing off. Thank you, everyone.
Thank you.
Thank you.